Deep dive on prompt engineering. Prompt engineering is the art and science of crafting effective inputs, prompts, for large language models, LLMs, to guide them towards generating desired outputs. It's crucial for maximizing the utility and performance of LLMs across various applications. Prompt engineering is all about learning how to talk to AI models like ChatGPT, Gemini, in a way that helps them understand exactly what you want. Core concepts of prompt engineering. Understanding LLM behavior. LLMs are trained on vast amounts of text data and learn patterns, relationships, and styles. Effective prompt engineering leverages this understanding to steer the model. Example: think of large language models like super smart computers that have read tons and tons of books, articles, and websites. Because they've read so much, they've learned how words go together, how ideas connect, and how different kinds of writing look. Now, when we do prompt engineering, it's like we're giving these super smart computers clues or instructions so they can give us exactly what we want. It's important to remember that these computers, pattern matchers, they identify and extend patterns in the input. Context aware, they use the entire prompt as context for generating a response. Sensitive to phrasing, slight changes in wording can lead to significantly different outputs. Probabilistic, they generate tokens based on probabilities, meaning outputs can vary even with identical prompts. Okay, imagine you have a super smart robot friend who loves to tell stories, but instead of just one story, it has a bunch of different ideas for how the story could go next. That's kind of how LLM work, especially when we talk about them being probabilistic. Prompt structure. A well-structured prompt typically includes role play, such as doctor, engineer, financial advisor. Instruction. The core task the LLM needs to perform. Likewise, summarize, generate, translate. Context. Relevant information or background necessary for the LLM to understand the task accurately. Input data. The specific text, code, or data the LLM should operate on. Output format, desired structure or style for the output, likewise, as a bulleted list, in JSON format. Prompting techniques. Zero-shot prompting. This is the simplest form, where the LLM is given an instruction without any examples. It relies solely on the model's pre-trained knowledge. Use case. Simple tasks like translation, basic summarization, or answering factual questions where the model has extensive knowledge. Example: translate hello to French. Few-shot prompting involves providing the LLM with a few examples of the desired input-output pairs within the prompt itself. This helps the model understand the pattern or task more specifically, especially for tasks it hasn't explicitly learned. Use case: custom classification, specific style generation, or tasks where the LLM needs to follow a particular format or pattern not inherently obvious. Chain of thought, COT, prompting encourages the LLM to perform intermediate reasoning steps before providing the final answer. This mimics human thought processes and can lead to more accurate and logical outputs, especially for complex reasoning tasks. Use case: mathematical word problems, complex multi-step reasoning, logical puzzles. Example: the unread messages in my inbox are 20. I received 5 new messages, and I replied to 3. How many unread messages are there now? Let's think step by step. Self-consistency, a technique used in conjunction with COT, where the LLM is prompted multiple times to generate several different reasoning paths and then the most consistent answer across these paths is chosen. Use case: improving robustness and accuracy for highly complex reasoning problems. Role prompting, assigning a specific persona or role to the LLM to influence its tone, style, and content. Use case: generating content for a specific audience, creating chatbots with defined personalities, or drafting professional documents. Example: act as a seasoned marketing expert. Write a compelling headline for a new productivity app. Delimiters, using clear separators, e.g., triple backticks, quotes, XML tags, to demarcate different sections of the prompt, especially when providing context or examples. This helps the LLM distinguish instructions from input data. Use case: when providing large blocks of text as context, code snippets, or multiple examples. Example: summarize the following text, which is delimited by triple backticks. Long text to be summarized goes here. Specificity and clarity being precise and unambiguous in instructions. Vague prompts lead to vague or undesirable outputs. Use case, all prompting scenarios. Poor prompt, write something about cars. Good prompt, write a concise, engaging paragraph about the environmental benefits of electric vehicles, targeting a general audience. Iterative prompt development, prompt engineering is really a one-shot process. It often involves experimenting, analyzing outputs, and refining prompts based on results. Process: draft initial prompt, based on the desired outcome. Test: run the prompt through the LLM. Evaluate: assess the output against the desired criteria. Refine: adjust the prompt based on evaluation, such as add context, change wording, add examples, specify format. Repeat: continue testing and refining until satisfactory results are achieved.